This conference will now be recorded.
Okay, so welcome back, guys. We are in day 14 session. So in today's session, we are going to discuss about what exception handling. Okay, so exception handling is one of the very important concept in the entire core Java because of we have one feature is there, one characteristic is there for Java. So what is that? Java is robust, meaning that Java is very strong. So why Java is very strong? Because in every situation, whether the end user is passing the correct input or wrong input, in any case, our project should be in a position to give the response. Okay, so that is what we call Java is robust. So such kind of robustness we are able to get by using one of the concept in Java, that is what exception handling. Yes, you need to understand so many things regarding this. Okay, first by seeing this name itself, you may understand, you may get it out. What do you mean by exception, right, sir? So generally, while you're writing the programs from the programmers, we usually get, if anything goes wrong, we usually get errors, meaning that so we have to compile the program, we have to execute the program. So while you are compiling the program also, you may get an errors. So such kind of errors are what? Compile time errors. Why compile time errors are coming? Because of if you are not following, okay, if you are not following syntaxes. If you are not following syntaxes, usually compiler will give you compile time errors. So what programmer will do immediately? Programmer will again open the code and accordingly where exactly he made those syntactical mistakes, and then he correct it, and then he resave and then recompile the program. That's it. So that is usually we are doing. But after compiling the program, we used to like what? Run the program. Actually, who is actually, who is the responsible person to execute or to run the program? JVM, of course. JVM is just straight away is not going to execute the program. For example, I'm performing addition of two numbers. If I'm passing 100 and then 20, immediately we are getting 120. That is fine. So that means JVM will process only valid data, valid input. Okay, JVM will not process invalid data intentionally or by mistakenly. If an end user is passing an invalid data, okay, JVM will not process that immediately. While you are executing, JVM is giving you errors. JVM will give you some errors. Okay, give you error. So what that error is, what we call technically exception. So JVM at what time is giving you this error? At runtime or compile time? Of course, it at runtime only. While you are executing the program, since end user is passing intentionally or by mistakenly that wrong input or invalid input, so if at any cost of time, if you are passing invalid input, JVM will not process that. JVM will give you the error. Those errors are what we call exceptions. Okay, so technically, if anybody is asking what do you mean by exception, you should say immediately it is a runtime error. Runtime error is nothing but what? Exception. Okay, this is what exactly the meaning of what exception. Sir, what we did actually when we are getting the compile time errors, what we did usually, okay, so wherever you made the syntactical mistakes, you go there and then correct it, and then accordingly we can overcome those compile time errors. So in the same manner, if I'm asking one more question, what you will do when you get the runtime errors or when you get the exceptions, what is your next step? Okay, so because of compile time errors, we are not facing any issues. But because of runtime errors, we have some drawbacks are there. Okay, what are the drawbacks? Drawbacks of runtime errors are exceptions. If you get an exception when you execute the program, okay, what are the exceptions? What are the drawbacks? Okay, so one second. All right. So what are the drawbacks of exceptions? Okay, it avoids, whenever exception occurs, control terminated abnormally. Okay, control terminated abnormally. Control terminated abnormally. Okay, I'll tell you, I'll explain, you just observe. And one more thing is, it gives system error messages. It gives system error messages which are not understandable by end users. Which are not understandable by end users. Okay, These are the two drawbacks which you are getting because of the exceptions. Okay, so what do you mean by control terminated abnormally? Sir, for example, I have a code, sir. Okay, I have a code something like this, so many lines of code. For example, say 1000 lines of code is there. So in the third line, you have one invalid data is there. Int x equals to 100 by 0. Resume something like this. You know, this is invalid data. So if it is invalid data, second line, first line got executed. When it comes to like what third line, JVM can't process this data. If JVM will not process this data, immediately from here only, from the third line only, it got terminated abnormally. If it is terminated abnormally, what about remaining 997 lines, sir? What about remaining 997 lines? Rest of the code will be executed or will not be executed? Simply, those rest of the code will not be executed. Simply, the entire code will become waste. So that is the first drawback. Very, very important drawback of what, if you are not handling the exceptions. So this is the first drawback. What is the first drawback? Tell me. Since if control got terminated abnormally, rest of the statements will not be executed. That is the first, okay, first disadvantage or drawback. And the second one is, because of this particular invalid encode, what is the output you are getting? Java.lang.arithmetic exception. Come on, please. Java.lang.arithmetic exception. Okay, colon divides by 0. So this kind of message, if an end user get a chance to see this kind of message, he might not understand, and from the next time onwards, he will not use your product if you are processing this kind of messages. Isn't it right? For example, if you go to your ATM machine to withdraw some money, okay, for example, in your machine, I mean, in your account, if you have like 10,000 rupees is there, okay, or else say something like, 5,000 rupees is there. But if you are trying to like what withdraw 7,000 rupees, immediately, are we getting any this something like exceptions? This kind of message, are you getting a chance to like what see in the console of the command ATM machine? No. Simply we are getting what? Simply we are getting what? Insufficient funds. Please check your account. This kind of message, please check your account. This kind of message can be easily understandable by every end user, so that he can understand what kind of mistake he did. From the next time onwards, he will try to withdraw from only 5,000 rupees only. So passing this kind of message is something like, system error message, and displaying this kind of message is what we call, user friendly message. So which one is more preferable? Of course, this user friendly message. If you are not handling the exceptions properly, what kind of message we are getting? Tell me. It gives system error messages which are not at all understandable by end users. That is not at all recommended, first of all. So that is the reason for sure you have to handle the exceptions. So if you get the exceptions, for your code, these are the drawbacks. What is the first drawback? Tell me. Control got terminated abnormally. Because of that, rest of the statements will not be executed. And the second drawback is what? It is giving you the system error messages which are not understandable by end users. That is not at all recommended. So, but if you handle the exception, okay, even though exception occurs, rest of the statements will be executed and the system error messages won't be displayed. We are just converting the system error messages into user friendly messages, so that end user can able to understand what mistake he did, so that he got some kind of realization and he will not do such kind of mistakes from the next attempt onwards. So that is the reason, even if you develop a simple piece of code also, you have to handle the exceptions. If you are not handling the exceptions, these are very, very creating so many problems. So that is the reason we have to handle the exceptions thoroughly, for sure. Yes, you may ask one question, sir, how can we handle the exceptions? How can we handle the exceptions? Yes, we can handle the exceptions. Using few keywords in Java. What are those? One is a try, catch. Okay, third one is finally. Fourth one is what? Throws. And the fifth one is what? Throw. Using these 5 keywords, we are able to handle the exceptions, and then we are able to escape from the termination abnormally. Okay, and we are able to provide the system error user friendly messages instead of system error messages. I hope you understand. How can we handle by using these keywords programmatically? That I will take care, no problem. But try to understand, this is the basic information why we should go for handling the exceptions. First, we need to understand about what do you mean by exception. Theoretical information is what? Theoretical information is what? Runtime error. Okay, why exceptions are occurring? Because of when you are passing the invalid input. Okay, logically, if something goes wrong, it will give you an error. JVM could not process that, and immediately error occurs. So that error is what we call, that runtime error is what we call technically exceptions. When you get the exceptions, what are the problems are happening? Okay, control got terminated abnormally, and system error messages will be displayed. So to avoid this, we have to handle the exceptions. If you handle the exceptions, what we can escape? We are able to maintain the normal flow of execution. Come on, please. Advantages of handling exceptions or runtime errors. What is the first advantage? Tell me. We are we can provide, or else we can achieve normal flow of execution. What do you mean by normal flow of execution, sir? Achieving normal flow of execution. What do you mean by this? Tell me. Even though exception occurs at some particular line, no problem. Okay, remaining statements will be executed successfully. That is the meaning of what? Achieving normal flow of execution. What is the second advantage? Tell me. Okay, getting user-friendly messages. Getting what, sir? Getting what? User-friendly messages instead of, okay, system error messages, which can be understandable by every person. But for sure, make sure that person is supposed to be like what, understand English language. Okay, so that is what you need to understand about what advantages of what handling the exceptions. How can we handle the exceptions? Like this, by using these 5 keywords, we are able to handle the exceptions. Yes. Now one more point I need to discuss here before we are moving into like what practical stuff. So types of exceptions. Types of exceptions, sir. How many types of exceptions? If I'm asking the same question with respect to packages, types of packages, we have like user defined and then predefined, right? In the same manner, types of exceptions are also what, sir? Predefined exceptions. Okay, second one, user defined exceptions. Okay, predefined exceptions are what, sir? Very simple, sir. These are the predefined classes. These are the predefined classes available in predefined packages. Okay, available in what? Predefined packages. So meaning that every exception is what? Internally, every exception is internally what, sir? It is a class. So this is programmatically with respect to API. If anybody is asking what do you mean by exception, you should tell it is a class. Theoretically, if they are asking what do you mean by exception, you should tell it's a runtime error. But practically, if they are asking what do you mean by exception, sir, tell me it is a class. Whether it might be user defined exception or predefined exception, whatever it might be. Sir, I wanted to show you, sir, few exceptions. So just open this. Okay, just open this arithmetic exception. Okay, arithmetic exception API in Java. Try to like what, Google it. So open the docs.oracle.com. You see, sir. So you see, what is this? Tell me. 1 second. Controller. Okay. So you just observe here java.lang.arithmetic exception. Sir, it is an exception class. So A should be capital, E should be capital. So available in java.lang. Why usually Java arithmetic exception got thrown? Arithmetic exception, when it occurs, when you are passing anything as a 0 as a denominator. So if anything is available inside the package, it might be a class or it might be an interface. So if you are observing here, what is this? Tell me. Public, come on, see, public class arithmetic exception. By this statement, do you got the clarity? Every exception is a class. Yes, every exception is a class, whether it might be a predefined or user defined, sir. That is very particularly specifically I am speaking, whether it might be user defined class, user defined exception or predefined exception. First of all, it is a class. That is what you need to remember. That is what you need to remember. When this arithmetic exception triggers, when number format exception occurs, when array index out of bounds exception, when interrupted exception, when IO exception occurs, when file not found exception occurs, that's a different story. But what my point I wanted to convey here is every exception is a class. Whether it can be applicable for both predefined and user defined. Of course, predefined exceptions are available in the predefined packages like this. User defined exceptions are available in our own packages. That is not a great challenge for us to keep the classes inside the package, right? And one more pointer I wanted to tell you here. Okay, sir, predefined exceptions. You may ask one question, sir, why predefined exceptions? Why user defined exceptions? These are all the points actually roaming in my mind, sir, actually. Okay, you supposed to like what think like that. So then only you will get the clarity on top of the concept. So now my next question is, why predefined exceptions, sir? Why predefined exceptions? Why they have defined? Why they defined and then why they are giving to out, sir? Just now I told you predefined, very very important. I am writing here. You try to understand. Predefined exceptions are the predefined classes. Okay, which are available in predefined packages. Okay, for the purpose is important. What is the purpose? Purpose of predefined exceptions is to handle universal problems. Very very important. To handle what, sir? Universal problems. Sir, what do you mean by universal problems? Sir, passing zero as denominator, of course universal problem. Yes or no? It's a common error. It's a common issue. For example, you are trying to perform arithmetic operations, sir, whether it might be addition or division or whatever it may be. You have to pass the integer. But if you are passing, okay, alphabet, okay, to perform arithmetic operation, obviously that is a blunder mistake. So it gives you what number format exception. It gives you what arithmetic exception. So and so like this, we have some particular specific universal conditions are there. Where if your program met that particular condition, immediately predefined exceptions are triggered by the JVM. Predefined exceptions. So ultimately my point is very clear. So why predefined exceptions are to handle universal problems, whether it might be arithmetic exception or number format or array index, whatever it might be. To handle universal problems, they are providing, Sun Microsystem people are providing predefined exceptions as a classes available by keeping those classes in some predefined packages. Don't feel all the exceptions are available inside the java.lang package. So it might be available in different packages also, sir. For example, I have interpret exception is there. Okay, interpret exception is also there here only, na java.lang. Any exception? Any exception? Okay. For example, IO exception. So this IO exception is available in which package? Tell me. Java.io. Okay. SQL exception. Okay. So like this SQL package, java.sql. Like this, we do have different exception classes are there available in the different packages. Sir, I wanted to show you, sir. If you click on this where frames is there, yeah, if you clicked on this frame, package is a collection of, when I clicked on this lang, package is a collection of interfaces, classes, enums, you see, sir, exceptions. See here how many exceptions are there. Arithmetic, array index, out of bounds, array store, class cast exception, class not found, illegal state exception, illegal argument, how many exceptions are there, you see. And along with that, errors are also there, annotations are also there. So my ultimate point is what? Package is a combination of including collections are also there. That is what my point. So and one more point is what you need to remember, and then clarity is what? Exception is a class only. So this is what you need to understand. Okay. So and when it comes to like what user defined package exceptions, sir, again I'm telling you, sir, user defined exceptions are also user defined classes, Java classes only. For the purpose is what? To handle what? Universal problems or our own problems? To handle our own problems. Sir, our own problems means what? That might be anything. So it is not fixed, anything based on your, for example, sir, I am performing, I am just entering, for example, I am calculating age. I am calculating age. So, for example, if you are passing age as what, -98, is it valid or invalid? It is an invalid. You should not pass the age value as what, negative. So then you will get invalid age exception. Sir, invalid age exception is available where, sir? It is not available anywhere. You have to define this one as a class. If somebody is passing age as a negative, throw this exception, trigger this exception like that. Okay. For example, if you are passing product weight as what, more than 100 kilos, this is valid product. For example, if somebody is not passing, or else less than 100 kgs, if somebody is passing something like 90, so based on the weight I am just checking, so throw the invalid, come on please, invalid product exception. See here, IPE is capital. So because of it, it's supposed to like what, follow the naming convention. So sir, conditions are always what, sir? Based on our own conditions. It might be anything. So just for simplification purpose, I am telling you. Okay, user defined exceptions are user defined classes, and those are going to be triggered based on our own problems. To handle our own problems, we are going to define our own classes as an exception class. Sir, I will tell you before this, yes, we will try to like what see you like what practically, but before this, what you need to understand is here. Exception hierarchy you need to understand. Exception class hierarchy you need to understand. If you really would like to learn this exception class hierarchy, first, as we said, predefined exceptions and user defined exceptions. Okay, user defined exceptions. Whether you believe or not, predefined, forget about user defined exceptions. Predefined exceptions can be divided into two types. One is a synchronous, another one is what? Asynchronous exceptions. Asynchronous exceptions. Sir, little theory is there, but if you are able to understand this theory, okay, practically we will get more clarity. For sure, I'm telling you. Okay, try to like what bear for this little theory. Once it gets completed, we can see it with respect to practical itself. Sir, synchronous exceptions meaning is what? Okay, asynchronous means what, sir? Which are triggering this kind of exceptions at runtime only, of course, but because of hardware failures. Because of what, sir? Hardware failures, sir, asynchronous exceptions occurs. Okay, because of programmatical logic errors, programmatical logical errors. Okay, synchronous exceptions will be occurred. So that is the reason, as a programmer, we are not going to handling these kind of asynchronous exceptions morely. Okay, we are only focusing on what? Synchronous exceptions only. Okay, we are only focusing on what? Synchronous. But still, okay, I will tell you out of memory exception, out of memory. This is related to like what, out of memory error. Okay, stack overflow error. Okay, stack overflow error, virtual memory error. Okay, like this, we do have like so many asynchronous exceptions are there. For all these asynchronous exceptions, one superclass is there. That is what, error. For all these asynchronous exceptions, okay, who is acting as a superclass? Tell me. Okay, error is acting as a superclass. Error is acting as a superclass itself. So now when it comes to like what synchronous exceptions, why we are getting these synchronous exceptions, sir? When you are making any mistake programmatically or logically, then we are getting these synchronous exceptions. So can you please tell me some examples? Yeah, sir, I will tell you just now. Arithmetic exception, okay, arithmetic exception, number format exception, number format based on your input only. This is giving you all this kind of exceptions itself. So if you are observing for all these exceptions, who is acting as a superclass? Tell me. Okay, runtime exception, sir. Okay, runtime exception. For the runtime exception, who is acting as a superclass? Exception. For the exception, who is acting as a superclass? Okay, for the exception, who is acting as a superclass? Object, sir. Okay, for the object, who is acting as a for the exception, who is acting as a superclass? Throwable. For the throwable, who is acting as a superclass, sir? Object. So this is the hierarchy, sir. This is the hierarchy. So just now, just before only I showed you one arithmetic exception. See here, java.lang.arithmetic exception. Superclass is runtime exception. Okay, runtime exception superclass is exception. Exception superclass is throwable. Throwable superclass is what? Object. Like this, you need to understand the hierarchy so that you can understand from which methods are coming from. Okay, our predefined superclasses itself. So you can easily understand in this way. Okay, so that is the reason, if any chance you get, you try to like what explore the class in this way, so that you will get the clarity what methods we are able to invoke by creating the object of this particular class. If any method is coming from our parent, by creating the child class object, we are able to like what invoke the parent class methods also. That is one of the very beauty of this particular concept. Okay, so you need to understand the hierarchy first. You need to understand the hierarchy itself. And moreover, for all the exceptions, whether it might be asynchronous or synchronous, who is acting as a superclass? Tell me. Throwable. For all the exceptions, whether it might be synchronous related or asynchronous related, for every exceptions in Java, who is acting as a superclass? Tell me. Throwable. Java.lang.throwable itself. And one more point I would like to convey here. Okay, since you have a segregation, since we have some separation is there, we have asynchronous exceptions, Synchronous exceptions. Asynchronous exceptions, why we are occurring? Because of hardware failures, so that you can leave for some time. That okay, we are not more we are not regularly using this particular asynchronous exceptions. Okay, asynchronous exceptions, because of it came because of hardware failures. So, and if you go to like what synchronous exceptions, since these exceptions are occurring based on the programmatical logical errors, so you need to like what little focus little I itself. What is that? In case of predefined, I mean in case of synchronous exceptions, who is acting as a superclass? Who is acting as a superclass in case of synchronous exceptions? Immediately the answer should be okay. We can't of course exception superclass is what? Here I am writing note point is for all yeah, for all synchronous exception. Okay, exceptions, for all synchronous exceptions, we are using java.lang.exception as the superclass. Here one more point you need to understand. Synchronous exceptions again can be divided into two types, sir. What are those two types? Tell me. Synchronous unchecked exceptions, synchronous checked exceptions. Okay, na? Synchronous unchecked exceptions, synchronous checked exceptions. You know who is acting as a superclass for the synchronous unchecked exceptions? Runtime exception. So by this you can easily guess it. Our arithmetic exception, number format exception, array index out of bounds exceptions, all these are the subclasses or child classes of which class? Tell me. Runtime exception. Again, of course, runtime exception is extending from the exception only. Exception is extending from throwable only. Throwable is extending from object only. That is, anyhow it was there. But what you need to understand, synchronous exceptions can be divided into two types. One is unchecked exception, another one is what? Checked exceptions. Unchecked exception superclass is runtime exception. That is what you need to understand. Hierarchy, first of all, you need to understand the hierarchy. Hierarchy is very, very important. Okay, now you may ask one question, sir, who is acting as a superclass for the checked exceptions? Very simple, sir. Java.lang.exception only is taking responsibility to make this particular exception as the superclass for all the checked exceptions. Unchecked exceptions and then checked exceptions. Yes, by the time while I am writing only, you may get this kind of doubt. Sir, what do you mean by unchecked exceptions? What do you mean by checked exceptions? It's a very, very important concept. What do you mean by, can anyone aware? So here, unchecked exceptions, the name itself, these are going to be checked at runtime, sir. These are going to be checked at what time, sir? Runtime. And the checked exceptions are checked by checked exceptions. Checked exceptions are checked by whom? Java compiler at morning only. 1 second. So checked exceptions are checked by the Java compiler only. Okay, why these checked exceptions are checking by the Java compiler? To escape from runtime error, to escape from runtime errors. This is what you need to understand. Okay, yes, you may ask one question, sir, what do you mean by checking by the Java compiler at compile time to escaping from the runtime errors? Yes, there is some ideology. I mean, there's some cases there. So whenever the case will come, you will get that point. I will explain you while I'm giving you the differences between checked exceptions and then unchecked exceptions. But so far, what is my conveying point is what? For all the unchecked exceptions, java.lang.exception is acting as a superclass. For all the checked exceptions, for all the synchronous exceptions, java.lang.exception is acting as a superclass. For synchronous unchecked exception, runtime exception is acting as a superclass. For synchronous checked exceptions, again java.lang.exception only is taking the responsibility. Okay, so try to understand. So these things we will see, try to like what practically we'll see, so that you will get more clarity itself. So first I wanted to like what show you one program without handling any exception, so that you can understand whether really whether we are really avoiding the abnormal, I mean we are facing the abnormal termination or not. Okay, all these things we can practically, if you see, so then you will get the clarity itself. Okay, so let's open my Eclipse. Just wait, sir. Okay, if I clicked on the launch, just wait, sir. It is just opening. Okay, so since it got started, let's try to like what create. I can show you also, sir. One diagram also I can show you. Exception class hierarchy. If you observe images, so that you can observe. We get so many. See here. If I open this, or else 1 second. I need diagram, right? Okay. I need a diagram, exception class hierarchy in Java. If I clicked on this image, okay, you see, let me save the image. So if I open this download, so many are there. Okay. My goodness, sorry. Right. Oh my God, it is not clear actually. 1 second. Whatever the story I'm just telling you just now, the entire story is here itself. Okay. So save it, and if I open this, correct. So see here, and it got stored. Even if you can observe here, object is there, right? Okay, object is the superclass. So as I said, we have a synchronous exceptions. Synchronous are there. So for all the synchronous exceptions, who is acting as a superclass? Exception. Okay. For all the unchecked exceptions like virtual machine error, assertion error, error is acting as a superclass. For all these, whether it might be synchronous or asynchronous, whether it might be synchronous or asynchronous, who is acting as a superclass? Throwable. Again, for throwable, who is acting as a superclass? Object is the root class. Adi gurtupettuko. Try to understand. Remember that. So here, as I said, uh, synchronous exceptions are again categorized into two types. One is checked exceptions. Another one is what? Unchecked exceptions. For all the unchecked exceptions, who is acting as a superclass? Runtime exception. Okay. For all the checked exceptions, of course, exception only is the okay superclass itself. Here it is not that much clear. Yeah. If you see, you just observe here. Runtime exception, arithmetic exception, class caster, illegal argument, index out of bounds. For all these are what? Unchecked exceptions. For all these unchecked exceptions, who is acting as a superclass? Runtime exception. For runtime exception, exception. And what is this class not found exception, file not found exception? Now, what are all these? These are what? Checked exceptions. Okay. So for these checked exceptions, of course, this is only the superclass. What are all these things? Interrupted exception, illegal access, instantiation exception. For all these things, who is acting as a superclass? Tell me. Error itself. I think these are also comes under here itself. I have one diagram is there, one hierarchy is there. So in that particular diagram, yeah. Okay, here itself. Runtime exception is the superclass for all the unchecked exception. IO exception, SQL exception, broken barrier exception, all these are the checked exceptions. Not only one or two, sir. So many are there, but just for example, I'm showing you here itself. So the left hand side, green color are related to like what asynchronous exceptions itself. I will save one particular, a good hierarchical diagram, and then I will share it in the description or in the Git link also. I can share it to you. So in this way, you try to like what understand. Okay. So this is basically, the basic information. What do you mean by exception? Why should we go forward handling the exception? What type of exceptions we have? Who is the superclass for which exception? If it is a synchronous exception, who is the superclass? If it is an unchecked exception, who is the superclass? If it is a asynchronous exceptions, who is the superclass? All these points, at least you should have an idea. Otherwise, you can't handle the exceptions while you're doing the coding. So that is why I'm just telling you this entire as what a theoretical stuff itself. Okay. So with this, we just completed theoretical information about what exception handling. Okay. In my next session, I will show you how we can handle the exceptions practically using those 5 keywords like try, catch, finally, throws, and then throw. Thank you.
This